All right, welcome to Geometry 2-2.1. We're looking at properties of parallel lines, and in the previous unit lesson we kind of explored lines with transversals and some of the angles relationships that are formed there. Now we're going to be looking at parallel lines, but before we get into that, I just wanted to kind of review supplementary angles and vertical angles. Supplementary angles are when two angles add to make 180 degrees, so they equal 180 degrees. Two angles do. Or maybe a better definition is when two angles, the outside edge, so the outside edge of angle DBC and the outside edge of angle ABC form a straight angle, which a straight angle is 180 degrees. So let's look at that. So one more time, we have, angle ABC plus angle BCD, CBD, equals 180 degrees. I don't want to write it there. Let's do it here. Equals 180 degrees. And again, why is that? It's because the outside edge of these two angles forms a straight angle, which is 180 degrees. So you can see this is half a circle, 180 degrees. Now this is important to know what supplementary angles are when looking at vertical angles. So why is, if I'm trying to prove, and I'm just going to pick a different color here, if I'm trying to prove that angle UST is congruent to angle VSR. How could, visually we could see, right? These two angles, this angle is the same as this angle. We could see that visually. Why is that? Well, let's look at some let's look at this more closely to prove that. So first of all, we're starting with angle UST, and we know that UST plus angle RST, equals, and I'll just use different colors here, 180 degrees. We also know that angle RST plus angle RSV equals 180 degrees. And let me just point out exactly what I did here. UST, which is right here, plus RST, right here. Again, the outside edges form a straight angle, so these two things are supplementary. They add to make 180 degrees. In this next line here, we have RST again, plus RSV, so this one right here. Again, these two edges create a straight angle, and so these two things equal to 180 degrees because they're supplementary angles. You can see now from this, we have two lines that are equal to 180 degrees. And so I'm going to set this line and this line equal to each other. Now, forgive me, I'm just going to use black now. But angle UST plus angle RST equals angle RST plus angle RSV. And again, all that I've done here is I've set this equal to this, since both are equal to 180 degrees. Now, in this equation that we have, if we look at the subtraction property of equality, and I subtract RST from both sides, and I'm just going to use an eraser to do this. If I subtract this from both sides, what I have left is angle UST equals angle RSV. So again, UST equals RSV. So we've proved that vertical angles are congruent. Again, this is just kind of a base to establish what we're actually studying today. So just wanted to show vertical angles are congruent, as well as adjacent angles on a straight angle whose edge forms a straight angle are supplementary, meaning they add to 180 degrees. So let's look at our first postulate, which is same side interior angle postulate. And what this says is that when you have a transversal that intersects two coplanar lines, in this case L and M, their same side interior angles are supplementary. So 4 and 5, these are our same side interior angles, are supplementary, meaning they'll add to 180 degrees. I will say this, we're going to explore later proofs of all this, but I just want to explain what these theorems and postulates are talking about. Also, here's other two same side interior angles, 3 and 6. Same side interior angle postulate says that these two would be equal to 180 degrees. So if these two lines are parallel, their same side interior angles will be supplementary, meaning they add to 180 degrees. The next theorem that we're looking at, or first theorem I should say, is the alternate interior angle theorem. So alternate interior angles, again, would be angle 4 and angle 6. So let me just pull up this color here. So angle 4, excuse me, angle 4 and angle 6. And this theorem says that these two angles are congruent. And so you can see here to the right, angle 4 is congruent to angle 6. And again, we're going to go through proofs of this. A visual way of looking at it too is this. I can't move these lines, but if I were going to move line M here, and I'm going to move it up this way so that it overlapped. If I mapped it onto line L, so now it's the same thing here. What would happen to angle 6? Where would it go? Well, it's also going to move up, and this is going to be right here. This would be where angle 6 would move if I moved line M up there. And again, you can see vertical angles, right? And we know that vertical angles are equal to each other. They're congruent. In the same way, if I move that line up, where would angle 5 go? Let me do this. Angle 5 is going to move up and appear here, right? And these two angles are also vertical. And you can see again, they're equal to each other. So the theorem says alternate interior angles are congruent to each other. So these two are congruent to each other, and angle 4 and 6 are congruent to each other. And we'll go into proofs of those later. Just wanted to show you some visual things to help you understand it. Next, we're looking at corresponding angle theorem. And what this says is, again, when you have a transversal that intersects two parallel lines, in this case L and M, their corresponding angles are congruent. So here you can see we have a lot. Let me start with this. So angle 1, its corresponding angle is angle 5. Remember, corresponding angles are on the same side of the transversal and they're in corresponding spots. Angle 1 and 5 are going to be congruent to each other. Let's look at all of them. We also have angle 2 would be congruent to angle 6. We also have, I didn't see what color that was, red. We also have angle 8 would be congruent to angle 4. And all these things are written out here. Angle 4 is equal to angle 8. And last but not least, you can see we have angle 7, which would be congruent to angle 3. And I should actually mark these a little bit differently. But yeah. So again, corresponding angles theorem says all the corresponding angles, so 1 and 5 or 2 and 6 or 3 and 7 or 4 and 8, all these corresponding angles here, these four pairs, are congruent to each other. Let's look at the next one. Alternate exterior angles. Alternate exterior angles. So again, I've labeled these. Your alternate exteriors, you have angle 1 and its exterior, we're on the exteriors, but alternating, angle 7, are also congruent to each other. And so, let me pull up that color. Angle 1 is congruent to angle 7. And again, that's just written right here. I'll pull up the blue. Angle 2 is going to be congruent to angle 8. Again, we will go into the proofs of these, but I just wanted you guys to have some visual understanding of the book. Could be a little bit dry in explaining this. Last but not least, let's look at total what we have. Let's just look at all the congruent angles. So you can see angle 2 is going to be congruent to angle 4 because it's vertical. Angle 2 is going to be congruent to angle 8 because it's alternating exterior. Angle 2 is going to be congruent to angle 6 because they're corresponding angles. So that's kind of using everything we have. And you could see that angle 2 is equal to angle 4, and also equal to angle 8, and also equal to angle 6. And all these angles actually are equal to each other. They're all congruent angles. Again, let's start with angle 1. Angle 1 and angle 3 are vertical angles, so we know that those are equal to each other. Whoops, angle 1 is equal to angle 3. Angle 1's alternating exterior angle would be 7, so it also equals angle 7. And angle 1's corresponding angle, 5, are also equal to each other. So you could see when you have a transversal that intersects two parallel lines, there's going to be two sets of equal angles. In this case, they're labeled all the odd ones, and then all your even ones. And there's different theorems which prove that, which we went over. But and also, guys, look at it visually. I mean, you could largely see angle 1 is not the same size as angle 2, right? Angle 1, even just visually, is equal to angle 3. Now, we know that from because they're vertical angles, but if you looked at angle 1 and angle 7, you could see, again, angle 1 is not the same as 6, right? This is way smaller than angle 1, but angle 1 is equal to angle 7 or congruent to angle 7, and we know that because of the alternating exterior angle theorem. I'll say that. Good luck. Go ahead and continue on with your book work, and we'll talk to you soon. Thanks. Bye.
Made with Doodlecast Pro.